Alright, hi year 11s, this is Mr. Lim here again, and this is our 6th video on intermolecular forces on dipole-dipole. So let's get started. Alright, we're going to be learning about what dipole-dipole forces are, and then how you can increase them, make them stronger. Alright, let's get started. So if a molecule is polar, so now we are dealing with polar molecules. Last video we dealt with non-polar molecules. Okay, so then the electrons will be unevenly distributed and create two permanent dipoles. Okay, so remember, dipoles are effectively positive and negative ends. Last video we talked about temporary instantaneous dipoles called dispersion forces, but now we're talking about permanent dipoles. All right, so why are there permanent dipoles? Okay, well, remember, if the molecule is polar, the electrons will need to be unevenly distributed all the time. So if I have a look at then HCl, all right, we remember that the Cl minus is the negative end, this H plus is the positive end, and these electrons in the middle are generally going to be more closely aligned with that Cl. Because those electrons are aligned with that Cl closer towards that side, that makes that side negative and that other side positive. Okay, so there will always be a positive and negative side to this particular linear molecule, right? And then there are obviously many other molecules of different shapes, but they will always have permanent dipoles if the molecule is polar. All right, so let's move on. The permanent dipoles, which are present, will attract each other. The permanent dipoles of neighboring molecules. So the idea is that if you get two molecules next to each other, they will align themselves so that this side here will be the positive side, all right? This will be the positive side, this will be the negative side, and there'll be an attraction between those two things there. All right, so this is the dipole-dipole force. Oops, dipole-dipole force. Okay, so you'll see often Mr. Lim will abbreviate to dip, but the idea is that this is the dipole-dipole intermolecular force. Remember, these are between two molecules. Okay, so then molecules will then align and then have a lattice structure where polar molecules are arranged so that oppositely charged dipoles are next to each other, right? So the idea is that if you have lots of these, then oops, I don't want that. If you have lots of these molecules, they'll all arrange their positive and negative ends, right, in an appropriate fashion. Oops, that one's supposed to be a positive. That one's a negative. And then even underneath it, this will be the positive end, this will be the negative end, because you can even have dipoles on this side as well here. All right, and so these molecules will arrange themselves and then form attraction to each other. All right, so they'll form this nice little lattice structure with different shaped molecules. They can look a little bit funny, but the idea is that they still form a lattice where the positive and negative ends are attracted to each other and aligned next to each other. All right, so moving on, we can see that then the dipole-dipole forces, this electrostatic attraction, okay, the electrostatic attraction contributes to the attraction between the particles, which must be overcome to boil or melt. Now, see this word here, contributes. It's really important to remember that it's one part of the attraction, okay? Because remember, what did we say last video, is that dispersion forces are within all substances, and then some of them also have dipole-dipole and other things as well. All right, so the idea is that this dipole-dipole force is one of the attractions which contribute all together to form the sum of all of those, and we'll talk about that later on, but you'll be recognizing that substances don't just have dipole-dipole, all right? But again, the idea is that depending on the arrangement of the particles with the difference in electronegativities of the elements within the molecules, the strength of dipole-dipole forces can vary. All right, so the idea is that if you have something like HCl versus HF, okay, the F is much more electronegative, right? And remember, that's the thing that pulls the electrons to its side, and therefore that will be the thing that will make that a more polar bond. So this is negative, and this is actually double positive, or double negative, and this one is, oops, negative as well, but not as much. Okay, so you can have a more polar bond if you have a more electronegative substance there pulling that thing on that way. All right, and it can also be in the arrangement of the particles, but that's not going to be tested on. The idea is that you need to be able to look at, okay, if I have H2S and H2O, which one will have the stronger dipole forces? Okay, so remember, this is going to form both, are going to form V-shaped molecules. Okay, then this one here, which one's more electronegative, sulfur or oxygen? Yeah, this is why we learn the trends across the periodic table. Which one's more electronegative? The oxygen is more electronegative. Okay, which means that this is going to be the negative end, and this is going to be the positive end, but like a double positive. You can even just apply the positive ends to these hydrogens here. Right, whereas this will still be negative, but these will not be as positive. Okay, and we'll deal with those in the next video as well. So you can increase the strength of the dipole-dipole forces, which will increase the amount of energy required to boil or melt them, and due to the difference in electronegativity. All right, that's it. Adios.